Okay. So we are now looking at the set theory. Okay. So in a set theory, there can be a mathematical definition of a set. Of course, under set theory, just a number of terminologies we can use, but mathematically it has own terminology and notation, and therein lies much of its power. Okay. So a set is just a collection of items or events. All right. So in a set, we can have a number of events that are taking place in a set. That's why we can even have a Venn diagram where we have a collection of events where we can have this one is for set. This is it for event A. We can have this other one for event B. And of course, we can have a number of events taking place in this one. So we can have an example, this combination of items. So we can have event A, there can be event B, there can be event C. So just a collection of events is the meaning of a set. Okay. All right. So this is a Venn diagram. So you're just saying all these events are collected. Okay, so it's a collection of events, is a set. Okay, so we can have set A, we can have event A, event B, event C. All right, so the most basic notation of a set, so a mathematical term for a collection of objectives, like I mentioned here, is defined in a precise way so that any object is either in the set or not in the set. All right, so we can have items here where we are saying item A or event X as the number of parameters 2, 3, 5, 7, 8, 9. Then that of B as 1, 4, 5, 7, and 8. Okay. So from here, we can first of all, so we have this X. We can given at X, we are going to given at Y. So we can be asked to find what is X union Y. So when we are talking about the union, so this is the union, the meaning of union. So union simply means the collection of events or collection of sets. So union, when you come across the union set, so when they ask us to say what's a union set, is simply collection of sets. Okay, so it's a collection of sets. So this one is the collection of sets, is what we call the union set. So you can have those numbers that are there. Okay. Now the union simply means they're asking us to find what is the combination of these events or sets that we have here. So we have for X, we have that of Y. Okay, so from here we can see what is found in these two sets is what we call the union set. The collection of sets is a union set. So meaning here we can combine these two sets. That's what I'm trying to tell us, that we need to combine what is in X and what is in Y, and we come up with one thing. We are coming up with a union. We are coming up with come together for X and Y, what is here. But we should avoid the repetitions. You should not repeat the numbers that are there. So meaning it will be 1, 2, that will be a union set, 1, 2, 3, then 4. What is important here is to understand the concept and as we move, and then 5, and then comma, there's no 6 there, so don't force matters. Don't put a 6 when the 6 is not there. So you just look at what is there as we look at the items that are given. So 1, 2, 3, 4, 5, 7. All right, then comma 8 and comma 9. So this is the union set that we have. All right, so if the examiner would ask what is the union set between these two sets, okay, so X and Y, our union set is just simply the collection of sets. So meaning we are going to have 1, 2, 3, 4, 5, 7, 8, and 9. That's our union. Now, that's number 1. So we can get into the second aspect here, where we look at the intersection set. Okay, so we have the intersection. So we have this one. Okay, so intersection set simply looks at what is found in both X and Y. Okay, so intersection means what is common, the common events or common items that are there in both sets or events. So it is represented by X intersection Y is equal to, so X intersection Y is equal to, so you look at what is common in both X and Y. That is the meaning of the intersection set. All right. So what we are going to do now here, we can see the common event that is here in X and Y. We are getting, you can see that a 5 is appearing in event X, okay, and it's also appearing in Y. So you are going to say our intersection set will be a 5, and then we also check here a 7. These two, they represent the intersection set. Okay, so as we look at that, this is what needs to be understood. Okay, so that's intersection set, which is X intersection Y. The N simply means intersection Y. Then we can also go an extra mile from here, where we simply say the X complement. This symbol simply means complement. Okay, so means it. So here, this one means complement. It means what is not found in that set. Okay, so X complement simply means what is not found in a given set. That is what it means by a complement. Okay, so meaning as we get to what we have been given, our X complement will be equal to what is not found in X. So we can see what is not found in X here. All right, what is not found in X is just 1 and 4. So X complement is 1 and 4. All right, because the rest, we are simply saying what is not found in X. So 1 is not there and 4 is not there. So X complement is 1 and 4. Okay, so looking at set theory, this is what is very important to understand before we get into the details of what we need. So we have the union, collection of sets. Then we have the intersection. It's looking at the common items found in both events or both sets. That is the intersection set. And then the complement simply means what is not found in a given set, like X complement. Similarly, when we find the Y complement, we can simply say y complement here is equal to, we can check what we have here. What is not found in y? So what is not found in y there is 2. So we can check what is not found in y there. 2 is not found in y. So we have a 2 that is not found in y. Then we also have the other one that is not found in y there. We have a 3 that is not found in y. So we have a 3. Okay. Then the other one that is not found in y is 8. Okay. So this is about aspect of a complement, because the other ones that are found there. All right. So what is not found in y is 2, 3, and 8. So these 4 combinations are supposed to be understood. So we have the complement. First one is on union set, the collection of sets. Intersection set, we're looking at, we have a common aspect that is there. What is common? That is an intersection set. So we're looking at the common items. When looking at intersection, we are looking at common items. Okay. Then when getting down to the complement, we are simply saying what is not found in a given set. So this is about what this one goes on. All right, now we can represent, or we can present this information in a Venn diagram, just about what we have here. Okay, so we can present this information in a Venn diagram where we simply say our Venn diagram is going to be, first and foremost, we will say, so this is our Venn diagram we're about to do now. So you're going to get the Venn diagram. So here we can simply say we have our X, because we have already identified that we have the intersection set. So we can have an X there, and then we can have our Y there. So this is our Y, and then this is our X. So we know for our X, we have the intersection set is what we need to start with. So we have a 5. Here we have, so we put a 5 here. Okay, so there should be a 5. Okay, on the intersection. So this symbol, this part here simply means what is a common aspect. So we have a 5 and we have a 7 here. So this is on in the intersection set. What is common for both X and Y? That is the one to start with. Now, what goes on after that? We now look at what is remaining. For X, what is remaining there? It is a 2. Okay. So we have a 2 is there. So we can put fact. There is also, so there's fact here, there's also a 9. Okay, so there's also a 9 on the intersection set. There's also a 9 there on the agenda, on the common aspect. There's a 9. So even here, there's supposed to be a 9. Okay, on the intersection set, there's supposed to also be a 9 here, because you're looking at what is common to both events. So we said a 5, a 7, and 9. So there are 3 things that are there. So that is on the intersection set. And then what is remaining for X is a 2. You can write it, you can put a 2 here. Then a 3 should be here also. So it should be a 3. Okay, so we have a 3 here. So it should be a 3 here. And there should be an 8 for X. So 8. within here, you're going to put an 8 there. Okay. Then for y, what is remaining there is 1 and a 4. So 1 and a 4, these are the ones that are remaining. So this is on the Venn diagram. Okay. So an aspect of a Venn diagram, we are getting this one. All right. So x intersection y, these are the ones that we have here. Then our x, other variables that remain, we have a 2, we have a 3, and we have 8. And then here we have a 5, a 7, and 9. And then here on the y there we have a y. So meaning when we say x complement, meaning what is not found in x, in this symbol here, what is not found in this x, which is 1 and 4, the one we found here. Then getting down to the other one, similarly, the y complement simply means what is not found in y, which means 2, 3, and 8. So 2, 3, and 8. This is about the y complement. So we're just trying to present this data in detail so that as we go, you can understand thoroughly on these sets. Okay. So now we can have this one, an example here. There's a example, they build up on the one we are actually looking at.
Are there any questions so far? Any questions so far? Okay, so with what has been explained so far now, let's look at an example. And also I want you to participate. So in this example, we'll do one question together, and the other one will be a homework where you will be required to try out. So what we're just talking about is a basic. So we have a question like this that you need to look at in an exam setup, because what we're talking about were easy. Okay, so we have an ice cream parlor. It has the following customers. So what are we given in here? We have customers who have the following preferences. 170 liked what? Vanilla. 135 liked chocolate, and 103 liked strawberry. 100 liked vanilla and chocolate. 74 liked vanilla, and 52 liked chocolate and strawberry. Then 35 liked all the three, and 7 did not like any of them. So let's illustrate this using a Venn diagram. So I'm going to take this so that we work it out together. Okay, so I want everyone to participate. Let's see how this is going to be. So what have we been given here? How many flavors do we have?
We've been given 3 flavors.
Okay, what are the 3 flavors?
Okay, I can't read properly. I'm driving, but I'll try. Vanilla.
We have vanilla. We denote it as V. What else do we have?
Chocolate and strawberry.
Chocolate and strawberry. So chocolate we can call it C, and strawberry we can call it S. Okay. So we've said for this to be complete, we are drawing this Venn diagram. So whenever you're drawing this, to start with, you are better off starting where all of them intersect, right? So let's start with almost at the end. Basically, we are told that 7 did not like any of them, so this one will be outside. So we go to 35 liked all the 3. So where are we going to put the 35?
The intersection.
In the intersection.
The intersection where all the 3 meet, right? Okay, then what else are we told? 52 liked what?
Strawberry and vanilla.
52 liked chocolate and strawberry. So chocolate and strawberry is supposed to be 52. So what do we put here?
We subtract it with 35.
So strawberry intersection what? Chocolate. We're going to do what? Subtract it. So we have already been given a 35, which is inside there. So we're going to say 52 minus what? 52 minus
35.
35. What do we get?
17.
17. So we put it here, right? What else have we been taught? That 74 people liked vanilla and strawberry. So vanilla intersection strawberry is supposed to be what? 74. But already we have a 35, which is already
74 minus 35.
74 minus 35. What do we get?
69. No,
69. We're going to put it where?
no, sir. 9.
Here.
No, wrong, sir.
But here, right? So 69.
74 minus.
Are we
And
following? Are we
69,
working
sir.
together?
Yes, not 69, sir.
It's what? It's 39, right? So we're going to put our 39 here. Here we had a 17. All right. Then we go to where? We go to vanilla and chocolate. Had how much? Vanilla intersection chocolate. We had 100. Is it? Vanilla intersection chocolate. Already done with that one. Vanilla intersection chocolate. We had 100. So 100 minus what? 35. What do we get? We get a 65. So we put a 65 here. So what else are we taught? We're taught that 170, or we're taught that 103 like strawberry. So the whole lot of this strawberry should be 103. So strawberry only supposed to be 103. We subtract what is already there. Minus 39, minus 35, and minus 17. What do we get? We're getting 12. 12 is going for the strawberry. That's where the 12 is coming here. Then when we go to our chocolate, we're told that 103. 103 loves strawberry, then 135 chocolate. So chocolate is 135 minus what? Chocolate is in here minus all these, minus 65, minus 35, minus 17. What do we get? So we are getting 18. And finally, we have those that loved. So the 18 was for chocolate, 18 here, not here. All right, then we go to finally vanilla. What are we taught about vanilla?
170 people liked vanilla.
So vanilla is good. 170 minus what?
Minus 65, minus 35, minus 39.
Okay. We compute that. We're going to get a 31 there. And now we can answer, complete the survey. If we've done, how many liked only strawberry? How many liked only strawberry?
12.
Okay, so strawberry, only 12, yes. How many liked vanilla and chocolate, but not strawberry? Vanilla and chocolate, but not strawberry. So the notation is what? What are you looking for?
I think it's the intersection between vanilla and chocolate.
Okay. Vanilla
And chocolate.
and chocolate.
Yeah.
Okay.
Union.
Union the what? Not strawberry. So we're looking at vanilla and what? Chocolate. All these, but not strawberry. So the complement of the strawberry. So we can look at all these, but whatever touches strawberry, we should negate it. So it will be 31 plus 65 plus 18.
65 plus 18.
Then how many like vanilla or chocolate, but not strawberry? Vanilla or chocolate, but not strawberry. Yes. What's the difference there? And represents what? In certain notation, or represents what?
Union. Union.
Which one represents union?
And
No. O is one that represents what? Union.
okay.
In and represents what? Okay. So what we did at first, we said vanilla or strawberry, but not vanilla or chocolate, but not strawberry. Vanilla or chocolate, but not strawberry is actually what we did. So vanilla or chocolate, we're uniting them, we're adding these. Vanilla plus chocolate, we remove what is found in here. So this answer that you gave me is actually for this part here. 31 plus 65 minus what? Plus 18. So this one will ultimately give you 114. Now the question is, what is the proportion of people who liked vanilla and strawberry, but not if n means intersection? Who liked vanilla and strawberry and chocolate, but not strawberry? Who wants to try? Liked vanilla and strawberry. So it is as good as they liked only vanilla and chocolate. That's all. So which is giving us 65. So it's simply the intersection. Okay, so here it is 65. Then how many liked strawberry or vanilla? Or means what? Union. So how many liked strawberry or vanilla? We're adding the whole lot of strawberry here and liked what? Vanilla. So we're also adding this part there. So the notation will give us what? 31 plus 39 plus 12 plus 65 plus 35 plus 17, which is 199. Then how many liked only one flavor? Which ones are the one flavors? So we're looking at these ones that are singled out. 31 plus 18 plus 12, which is 61. Are we together? Is anyone behind? Is anyone lost?
Yes.
Okay. So I've sent this work on the group. second question. I don't know whether you can do it on your own or we try it together. So we try the second one together.
We can do it together, sir.
Okay, so we now look at question 2. I'm sure the other question has been explained. All right, and using the Venn diagram that's been very clear. Okay, so we can now look at question 2. Okay, so question 2 it says the Department of Transportation is negotiating a contract regarding the roadway improvements. It is estimated that there is 55% chance that an agreement will be reached on bridge B. So meaning that we have probability of B, okay? So probability of B is actually equal to what? 0.55. Are we together? So the probability of B, which is probability of B is what? 0.55. Okay, are we together there?
Yes.
Then it is estimated that there is a 5% chance that an agreement will be reached on a highway paying, which is the H improvement. So probability of H. So probability of what? H is equal to what? The
0.65.
Correct. So here 0.365. All right. Now, what they're saying here now is that there is a 30% chance that no agreement will be reached on either issue. So meaning they're simply saying that probability of B, when they say either, it is meaning addition. All right, so either means addition. So we have a probability of B union H complement will be equal to the 0.3. That's what they're saying here. Because they're saying there is a 30% chance that no agreement will be reached on either issue. All right. So probability of B union H is 0.3. That's what it means. Okay. So meaning that, are we together?
Yes.
So meaning of probability of you can give me the probability of B union H. What will be a probability of B union H? Okay. So it is a complement that's been given. So meaning of probability of B union H will be 0.7. Are we together?
Yeah. Yeah.
Are we together there? So you're simply saying, is that okay?
I'm behind. I'm a bit behind, sir.
Okay. What we are simply saying is this. That's why I was trying to explain that a complement of an event simply means what is not found in an event, not so.
Yes.
So they're simply saying that there is a 30% chance that no agreement will be reached on either issue. There's a 30% chance that no agreement will be reached on either issue, meaning that probability of B union H complement is 0.3. Are we together? Okay, if they say the probability of A complement is 0.4. Okay, meaning that if it's an example, probability of A complement, if it is A complement, if it is 0.4, who can give you the probability of A? If its probability of A complement is 0.4, okay, what is the probability of A? Our probability of A will be 0.6. Are we together? So we are simply saying what is not, so meaning that probability of A complement and probability of A should give you 1, because the total probability should give us 1 always. Is that clear?
Yes.
No.
Are we together? The sum of
No.
probability, the sum of probability should give us what? Always what? 1. Are we together there?
Yes.
The total probability should give us 1. So what is found in A and what is not found in A, when you sum up, they should get a 1. Is that okay?
Yes.
So it should give us a 1. So now, I'm sure you have understood the probability of B, the 0.55, the probability of H, 0.65. Now, what is not found in B, or when they say either, simply means they are looking at a union. Either means it's a union. So this one simply means union. All right, when they ask you to find when they say and, means it is intersection. Are we together?
Yes.
If there's anyone behind, please let me know. So now, when they ask you to find the probability of B intersection H, okay, so probability of B intersection H is what they're looking at now, okay? So there is a formula we use here. The formula is the probability of B union. This formula, you should just understand it the way you go about. So B union H is equal to probability of B. Okay, so you're going to say probability of B, then plus the probability of H. All right, then minus, so the probability of H here, then minus probability of B intersection H. This is the formula we need to go for, please, as we are looking at a question like this one. So this question was not a straightforward question. It was need to go deeper. All right, so you can now substitute here so that we can find the probability of B intersection H. Okay, are we together up to this level here? The probability of,
Yes.
yeah, so the probability of B is 0.55, probability of H is 0.65. Then probability of B union H complement, which is there's 30% chance that no agreement will be reached on either issue. So meaning that probability of B union H complement is 0.3. So meaning that when the probability of B union H is 0.7, so that when you add these two, you should give you a 1. So you can now come here and substitute to say this is the 0. What? The 0. B union H is 0.7. All right. So here you're going to say 0. What?
7.
0.7. Okay, which is equal to what? Probability of B. We know what is the probability of B?
0.55.
Okay, so 0.55. So we can just using equations there, we can sort out. Okay, so we can, here is 0.55. Then, so we have the 0.55 here. Then the other one is, okay, so the other one is plus probability of H is 0.65, right? So this is 0.65. So let's solve for the other one. So when that one crosses the equal sign, it will become what? a plus, not so. Are we together?
Yes.
So what you do, you will take this one, which has a minus here. When it crosses the equal sign, it will come the other side. So it will be probability of what? Probability of B intersection H. Who can give me the final answer now? When we use making this one the subject formula, when this one crosses the equal sign, it will be what? What answer are we going to get? The 0.7, it will come the other side to be minus, not so. Are we together?
Yes. Yes, sir.
So meaning that we are making the subject of the formula there. So what will be our B intersection? That's the question. It says find B intersection H. So our B intersection H will be what? So it will be 0.55 using the algebra. When you can substitute there, when the other variable crosses the equal sign, I'm sure you will see what is going to happen there. So you can say minus, you can even say minus X here, because we don't know this value. So minus X on the other one. I'm sure you are together, not so. So we can solve for X there, right? So it will be 0.55 plus the 0.65, all right, minus the 0.7. What answer are we getting? What answer are we getting, please? Can somebody give me the answer? What answer are we getting? When we solve for this one, when this one crosses the equal sign, of course, I can still present this one in a Venn diagram so that you see what is going on here. All right. So the answer is 0. What? 0.5. Is there any question? Hello?
So how did 0.5 become the answer? That means X crossed, went over to the
And it became a
left
positive.
side.
Yeah, you know, when this one crosses the equal sign, it will be when here, check. If you can put, of course, we have the 0.7 here, which is equal to 0.55. So you can add the two. For 0.55 and the 0.65, what answer are we getting? 0.55 plus the 0.65, we are getting what?
Giving us 0.12.
So no, just add the 0.55, then plus the 0.65. What are we getting?
0.55
Plus the
plus
0.65.
0.65. It's giving us 1.2.
Yeah, so I want, so meaning that it would be like you are saying 0.7 now, okay, is equal to 1.2. I'm sure you know where 1.2 is coming from, not so?
Yes.
Then 1.2 minus 6, probability of B intersection H. Okay, you've seen that, right? So we can now let this one come the other side because it has a minus to become a plus. Are we together?
Yes.
So when this negative probability of B intersection H come the other side, to be probability of what? B, okay, intersection what? H, which is equal to what? Which is equal to 1.2, right? Are we together?
Minus 0.7.
Yes. What answer are we getting?
5.
Come again?
0.5.
That's the
0.5.
answer which I found here, which is the one I have mentioned. That's where the 0.5 is coming from.
Okay.
Is that clear?
But is it okay when it's before you add the 0.55 plus 0.65? Is it okay if we can just connect the like them together just there and then?
Yes. That's what I did actually. You can do either way. In mathematics, there's no problem. as long as you arrive at the same answer. So you can do it the other way around. You can collect the like terms here, and you can still solve. You can still solve it. We still give you the same answer. You remember that like terms issue, not so.
Yes.
So that's how the 0.5 is coming from. So if you can present this information in a Venn diagram, you have the intersection of probability of intersection B intersection H 0.5. So you can even do this Venn diagram where we say B intersection H, right? So here we have this one. Okay. So this is it. B, okay, intersection H. You can present this formation in the Venn diagram, which is it, the 0.5. Okay. Okay, sorry. The 0.5. This is a point. Forget about it. So 0.5 here. So you have the 0.5. Okay. Here. Then you can give me what is for B. What's probability of B? 0.55. Not so. So what is for B only? Okay, this for the entire B is 0.55, right? Are we together?
Yes.
So what is for B only? So we can subtract there now. 0.55 minus 0.5, which will give us the 0.05. So here is 0. What? 0. Okay, so 0. What?
0.5.
0.05. Okay. Then what is for H? Who can give me for H only? What is for H only? For H is what, 0.65. What is for H only? H only. H was 0.65. But what was the H only?
Minus 0.5.
So what is for H only? So you can see how detailed this question was. So we have the 0.3. So this is 0.5. So what was for H only? Who can give me for H only? So it will give 0.15. So for H it was 0.65, not so. Are we together?
Yes, sir.
So for H was 0.65. Now for us to find for H only, we are supposed to, this is the entire H here. So for H only, it will be 0.15. 0.15. You get the point, right? So there's a point here, 0.15. So this is, so take this one as it. Okay, just cancel. This is 0.15. So this is 0.15. Is that clear?
Yes.
So okay, so this is what we have. So now, if you want to find the union set for the collection of all these, it will give you the 0.7. So when you add, so what is not found in, so probability of B union H, you simply add. So start adding, please. If you want to confirm probability of B union H, all right? Are people following?
Yes, sir.
So when you say probability of B union H, simply means what is in B only, or what is in both, or what is in H. So just add it for me. You simply say 0.55. So just add the 0.55.
Yes, sir.
So just add for me 0.55. So you are going to have 0.55. Then plus the 0.5. Then plus the 0.15. It should give us what? So 0.55 plus the, okay, so 0.55, then plus the 0.5, then plus the 0.15, the 0.15. 15. What answer are we getting?
We're getting 1.2.
No, add again the 0.55 plus the was getting sorry, the 0.05, which is this one. The 0.05, you've seen the 0.05 from the Venn diagram. So this is the Venn diagram. You are there, eh?
Yes, sir.
This is the Venn diagram. We are getting what? The 0.05. You've seen it, eh? So this is 0.05, which is this one here. Then plus the 0.5, then plus the 0.15. What answer are we getting?
So 0.05
0.7.
plus.
Correct. You've seen this is the 0.7 which I gave you here. Are we together now?
Yes.
Is everyone there? Are you able to follow through? So this is where the 0.7 is here now. The one I gave you initially to say B intersection H 0.7, which is the same one we have confirmed it here that we have found. Okay. So we have gotten the 0.7. Is everyone clear?
It's clear, sir.
So meaning is the union, you are collecting what is in B and H, everything. So it's 0.05, the 0.5 and 0.15. So 0.7, the one I gave you here. So what is not found in B and H is the 0.3, you put it here, which is the one they gave us in the question. Have you seen it? The 30%, which is here, is the one that was given in the question. Okay. Okay, so this is how the breakdown has come about. You've seen the Venn diagram. The 0.05, the 0.5 was intersection set. Then the 0.15 is there. So the collection of all these, we have gotten the 0.7. So this is where the 0.7 came from. So what is not found in B and H? You can see from this question. What was not found in, there is a 30% chance that no agreement will be reached on either issue, meaning on the Department of Transportation or on the other department that was the agreement based on the bridge improvement. Okay, so bridge improvement and transportation. So there's a 30% chance that no agreement will be reached on either issue. Are we together there?
Yes.
Unless somebody is behind. So this is how you go about it, this kind of equation. So they wanted us to find the union set. The union set here, making the subtotal formula using that one, it is actually the 0.5. So we have gotten the 0.3 on either issue, meaning on B or H, there was 30%, which is there. Also you've seen in the Venn diagram, there's 0.3 that is there. Then for B or H, the union set, it's here, the 0.7, what is in B or H, okay? Because on either issue, it was what was not found on either issue was 0.3, so meaning that B intersection, B union H complement was 0.3. So just manipulating that formula now, this is how we actually obtained this solution. All right. Is that clear?
Yes, sir.
Okay.
So if there are any questions you could ask, are there any questions at this point you could ask? So sometimes people think sets are very easy, but they have their own complexities. All right. So we're going to look at another question under set notation. If there are no questions here, we're going to look at another question on set notation where I'll need your participation. Okay. If there are no questions, I'll bring in another question where I require, similar to the one that we did.
Can we do something similar to what has been done? This second question.
Okay, something that has been done. Similar to this question.
Yeah, like this. It's similar to the second question.
Okay, this one is a tricky one. Okay, let's find something that is close to this one that we can. But I'll need you to participate. Okay.
Yeah, because I need to know where the 0.7 came from. I've been like off air from there.
Okay. Who else is lost on this one?
Pardon?
You want us to go through it again, or you are just you want us to do a similar question?
If we can do a similar question, or if we can go through this one, especially where before we did the Venn diagram, where the B union H, the 0.7 came in.
Okay, let's go through it again. The Department of Transportation is negotiating a contract regarding a roadway. It is estimated that 55% chance that they will agree. So we are going to use our own notations. So there's a chance that they will agree on the bridge agreement at how much? 55. So we can call the probability B as what? 55.
Yeah.
0.55. Are we together?
Yeah.
Then also we are told that the chance that there will be an agreement on the highway will be 65%. So probability of H is 65%, 0.65. Are we together on this one?
Yes.
Okay. Then we are told that the chance that there is no agreement is 30%. All right?
Mm-hmm. Yeah.
Meaning there being an agreement would be what? If there's no agreement at the 30%, meaning agreement will be B union what? H. So them agreeing is what? 70%. How about them agreeing? Them not agreeing is the opposite. B union H complement. It means they have not agreed. That's why we put a complement there. It's 0.3. We're together?
Yes.
Yes. So now they're asking us to find B intersection H. So we know that the formula for B union H using the set notation is supposed to be what? Probability of B plus probability of H minus the intersection of B intersection H. So what's the probability of B union H? 0.7. What is the probability of B? 0.55. What's the probability of H? 0.65. Then what we're looking for is what? The intersection.
Yeah.
B intersection H. So what happens? Inga isoku, it will be the subjective formula. So B intersection H will simply be 0.55 plus 0.65 minus 0.7.
0.7. Yeah.
Collectively, what we get? 0.5.
0.1.
So is it clear now?
Yes.
This is what we did just from explaining right now. All right. So in 5 minutes, we'll be looking at the part that also includes microeconomics, but also in here. So let me just look at another part of the notation that we can understand. So about all them axioms of probability. Probability of A times probability of B gives you what? An intersection of A intersection B. So times it is the same as what? The word and or the sign intersection. Then probability A or B, or means what?
Union.
Good, union. So this is union. It is also addition. So this gives us A union B is given by what? Probability of A plus probability of B minus the intersection. Right together?
Mhm.
So if you're illustrating it, A union B, you add what A has and what B has, then you subtract the intersection. Are we together? Why do you
Okay.
subtract the intersection? Because already in both, you end up duplicating. If you're taking three courses and your colleague is taking 3 courses, you're sharing mathematical analysis. So it's 3 plus 3 minus mathematical analysis because it's already there. Are we together?
Yeah.
Then probability of A plus the complement. Complement is what you don't have. All right? Should give us 1. So based on these 3 formulas, suppose you're given A as 0.2, you're given B as 0.3. Can somebody help us find the intersection of A and B? How do you find the intersection of A and B? Huh?
That is the intersection of A and B is we're multiplying 0.2
0.3.
by 0.3.
Yes, correct. Why did you get it like that? Because and is what? Intersection.
Intersection.
Good. How about the complement of A? What is the complement of A?
That is 0.3.
It's what is outside A. If A has 20%, what doesn't A have? A and its complement must add up to 1. So it's simply 1 minus A itself. Is 8 correct? So 1 minus 0.2 is 0.8. So tell me, what is the complement of what? Of B?
0.70.
Is it right?
1 minus 0.3.
Yes.
Yeah, it's 0.7. 0.7.
So how do we find the union set therefore?
The union, we add the probability of A plus the probability of B minus the probability of intersection B.
Is it right? Probability of A
Yes,
union
it
B
is. Yes,
is
it
given
is.
by, let me check, probability of A plus probability of what? B
B
minus the what?
minus the
Intersection.
intersection set.
Good. What is our A?
0.2.
Our B?
0.3.
Our intersection?
0.06.
And what do we get?
0.44.
Excellent. All right. Sometimes we may be given sets like this: A, B, X, and Y. We're given 2, 4, 6, 8. So we'll be asked to find the probability of what? A. What's the probability of A? First, we find the totals. The total here is what? 6. The total here is what? 14. The total here is what? 8. The total here is what? 12. The total of totals is what? 20. Okay. So probability of A is the number of elements in A over the total sample space. So how many A's do we have? A is 6 out of the total. Here is what? 20. You get 0.3. So can somebody help us? What's the probability of B? The total for B is what?
14, 8,
B is 8
8.
out of
8
20,
over 20.
which is 0.4. About X?
So I don't understand how you're dividing. I don't know if you're dividing or I don't know,
The
subtracting.
probability of A, you got the total for A is what? 6 out of the total here, 20.
6.
Probability of B is 8 here, the total out of the total of totals, 20. So tell me what's the probability of X?
It's 12 over 20.
Excellent, 12 over 20. 0.6. About Y?
14 over 20.
14 over 20, correct, 0.7. Then A intersection B is where they meet. A and B, they meet when you draw a plus here, they meet at 2. So 2 over 20. 0.1. How about X intersection Y? X intersection Y, where do they meet?
It's 0.6 plus 0.7.
Where they meet X and Y, they meet at 8. So we're going to put 8 over what? Over 20,
Okay.
0.4. How about A intersection X?
Meet at 4,
So 4 out of what?
20.
20.
How about Y intersection B?
6 over 20.
6 over 20.
Good. How
Sir,
about
just a minute, just a second, sir. I think I'm a bit bent. These answers, are we dividing the 4 into 20 or subtracting the 4 into 20?
No, just
What's
dividing
happening then?
20 into 4.
Okay, I get.
How about A union B? Probability of A plus what? Probability of B minus what?
B.
Intersection.
That's the probability of O intersection B.
What do we get? Probability of A was what?
Right,
0.3.
I was 3.
Probability of
0.3.
B 0.4.
0.4.
0.4.
And the intersection?
0.4.
The intersection of A and B? 0.1.
0.1.
Then what do we get as a total? 0.6. What is X union Y?
And Y.
0.6 plus 0.4.
Zero 0.6. That's 0.5. 0.7. No.
Minus 1. Intersection.
So what's the formula? Probability of X plus what?
Plus probability of Y minus probability of X intersection Y.
Okay, so what do we get? What are you getting?
Zero 0.9.
0.9. Okay. So we get 0.9 as the final answer.
Did you use this one? It was just
Okay, so I think I'll give you homework based on what has been done today. Are there any questions? Is this clear?
Yes.
It's very understandable. So I only give you 5 questions. You choose any 4. All right. So we end here for now. We're going to end here.